page 122 of your student journal is going to introduce the chapter by reviewing what we've already done in the past about dealing with exponents, rational exponents, and dealing with different radicals that maybe you've had some experience with in the past. We also have some literal equation stuff on there. But I want you to work through page 122 with your groupies. I'm only going to give you about 10 minutes on this, so get as far as you can in that time. If you want to touch on each part, maybe work down the columns. Okay. Hey, can I have your attention back up here?
No, it's 2.
Eyes and ears focused up here.
That's still 6.
Okay. Right here. C to the first, C to the ninth, that is C to the 1 plus 9 is C to the 10th. This is Q to the 12 minus 4, which is 8. So remember your rules here of exponents. When you're multiplying with the same base, you add the exponent together. When you're dividing with the same base, you subtract the exponent. This is really going to help you get set up for next chapter, which we start dealing with exponents, exponential functions, and logs. Okay? So log functions. So most of you haven't dealt with logs, so that'll be a new experience there. X cubed, x to the, we have x cubed on top, x to the 9th on bottom, which gives us x to the 3 minus 9, which is negative 6, which we don't write as x to the negative 6. It's 1 over x to the 6th. Hey, the other way to think about it is you have 3 x's on top, 9 on bottom. You have 6 more on bottom. Okay, you could write it out in expanded form and cancel them out like that. You have that. All right. Hey, this one right here, d squared. Think of that as having a 1 under it there. That gives me 8 times d to the 2 plus 5 over d, which would be 8 to the d to the 7th over d, not over 9, but over d. Okay, and then one of those would cancel, so you'd be left with d to the 6th on top, so 8d to the 6th. Could have done that in a much faster way, but that's fine. You could have canceled here and called that just d. You get 8d to the 6th. Okay, whenever you have power outside, remember you distribute it in. That is 4 squared. And x to the 3rd times x to the 3rd, which is x to the 6th. So you multiply the 3 by 2. Okay, so on top you get 4x to the 6th, and on the bottom you've got to square the 2 and square the y to the 4th, so you have 2 squared and y to the 4th times y to the 4th, or y to the 8th. 4 squared should be 16. Yes, that's a good point. Thanks for pointing that out. My goodness. Okay? Hey, and then what happens here? Good, that cancels. So we get 4x to the 6th, y to the 8th. Once again, you can do it different ways. Okay, you may have got there a different way, and that's okay. Here I'd probably simplify first. Gives me m to the, what's that? 11. And here, can't simplify that. So you have m to the 11th over n times m, all to the 3rd. You can cancel an m, and call that now m to the 10th. And then you bring in the 3 to both. Gives you m to the 30th over n. So just a quick review of what we've done in the past. This would be n to the 30th, yes. Sorry. To the, 3rd. My goodness. What's that? Because we canceled an m. Yeah. Okay. you guys, the next section, we're dealing with literal equations. That means you're solving for that variable. I'm not terribly concerned about spending a lot of time on that. I'll put up the answers here real quick for you. You can see how we should have got. Negative x plus 1, 16x plus 2, and that one's ugly. Negative 24/5 x plus 74/5. No, solve for y. Okay, a couple of ways you could write this one. You could leave it as negative 72 over 6x plus 3, or simplify it by factoring that out, which actually would be better, negative 24 over 2x plus 1. Okay? The last problem is the one that I want you to spend some time on, though. Number 13. Which one is it? Is it equal to that, or is it equal to that? Does this simplify to, we'll call that one A and that one B? How many say A? How many say B? How many say A? How many say B? Some of you don't have. All right, come up with a consensus at your table, please. All right, how many say A now? B. Hey, well, let's see. I'm going to put the, well, I guess I could use either one. That's 4x. That's 3y. So I now have 4x over 3y all squared. Anyone want to change from A to B or B to A? How many say A now? How many say B? B. It is B. Yes, you're squaring both parts. You got to distribute that 2 to all parts there. There we've got it. Okay, any questions? Yes? Page 123. Okay, I'm giving you about 2 minutes to do exploration 1. You'll come up with some questions, I'm sure of that. 2 minutes. Here we go. So, what kind of questions came up? Go for it. Yeah, we'll get to that. Yeah. Okay, what kind of questions came up on how to do these? Yeah, Emma. Okay, hold on one second. You guys over there talking, it's really hard to focus on what she's saying. What's that? Yeah, this little number right here is called an index number. Okay, that's saying the cubed root. One number times itself 3 times makes 8. The way you enter that on a graphing calculator, you're going to hit math, and then you're going to go down to option 4, and then you can put the 8 in. If you don't want to use that, you could hit math, actually put the 3 first, and then push math, and go down to option 5, and then it puts the cubed in for you that way. So if you're doing, say, like the 4th root or any root above the 3rd root, for instance, letter F here, you would have to push 4, and then math, and then option 5. That puts the 4th root of, I think it's 12. Yeah. Okay. All right. Hey, things that you kind of observed, Emily pointed out there that this right here, it's a little harder to see with that one. Maybe we move to, say, like this one. The cubed root of 3 is the same as 1, or 3 to the 1/3 power. That, whatever your index is, becomes your denominator. And if you don't see an index number, that's always implied a square root. You think of it as a 2, so it's 1/2. Yeah? Yeah, if it's an 83, I'll have to work with you on it. Okay? All right? So, you guys, just so we're clear, when you're doing the fourth root, that's same as raising something to the 1/4 power, which is much easier a lot of times to write it as an exponent than as a radical. Makes it a lot easier, especially when you're dealing with logs. Okay? So knowing that the fourth root is the same thing as a 4th power. Okay, I want you to go ahead and move on to the bottom here. Exploration number 2 is work with a partner. Use the definition of rational exponents and properties of exponents. Okay, that's some big terms there. Okay, too much talking. Okay, rational exponents, properties of exponents, to rewrite each expression with the base as a single exponent. Kai, Derek, you guys know what you're doing here? No? But you're distracted. You're like in the middle of the class talking. That makes it tough on everyone around you, not to mention me when I'm trying to read. Not my strong suit, dude. Okay? Then use a calculator to evaluate the expression. So if I'm dealing with a rational exponent, that means an exponent. What's a ratio? A ratio is a comparison, or we call it a fraction a lot of times. Okay? So a rational exponent means a exponent that's a ratio or a fraction, or can be expressed as a fraction. And use your properties, the properties we used in the previous maintaining math proficiency there. Okay? So I want you to go ahead and change this to this form, and then come up with its approximation. Do that for each of those problems. That's really what it's asking you to do. Don't be afraid of making mistakes, right? This is 5 to the 1/2 power, all cubed, which is 5 to the 2/3 power, or excuse me, 3/2 power. Okay? And then that's approximately, or is it exactly? Approximately 11.108. 2 decimal places, I think, right? Yeah. Okay, so your index, remember, becomes your denominator. So that's 4 to the 1/4. And then all that's being squared. So then we square that. That becomes 4 to the 2/4, which is the same thing as 1/2, but that is 2. Okay. Any questions on them? All right, I'm going to put up the next 3, then you guys, we can move on there. But those are the next 3 solutions. Check your work. So everyone take a look at Exploration 3 now. Exploration 3, going the other way now. Writing it like this and then rounding it. Off you go. So you're kind of undoing this one, right? 8 to the 1/3 squared, which is the cubed root of 8, all squared. What is the cubed root of 8? 2. What's 2 squared? 4. Okay? Now you could have went the other way. You could have squared 8 first, which is 64, and then taken the cubed root of that, which is also 4. It's just usually easier to take the root if you can first. Not always. Okay, if it doesn't allow you to go perfectly the other way. Okay, so this would be the square root of 6, all to the 5th power. Square root of 6, see, that doesn't work. So, I mean, doesn't come out perfect. So that ends up giving you approximately 88.18. Well done, man. Fourth root of 12, denominator is the index. Numerator is the power. Okay, once again, can't take the fourth root of 12 perfectly. I'm going to get a rounded number here, 6.45. Okay, how many are getting them? Okay, I'm going to put the next three up there just so you can see them, and then we're going to hopefully move on to the last bit here. There you go. Check them out. 31.62, 64, and 36.41. Key also is writing it in this form, square root of 10 cubed. Now, you'll notice that on mine here, I actually brought in the 3 rather than leaving it as this. I actually brought the 3 into the 10, and you can do that as well. Okay? What's that? So this could be also like that. You could write it out like that. It doesn't matter which order you go in, so either way would work on it. Okay? All right, the next piece, I want you to go ahead and take a look at you can do number 4 on your own later, summarizing your unit, but go to number 5, and without a calculator, I want you to go through and complete those. Hey, letter A. So this is saying the cubed root, or the square root of 4 to the third. What's easier, the square root of 4 or the 4 to the third? Square root of 4. Square root of 4 is 2. So we have 2 cubed now, which is 8. Okay, we could take the 5th root of 32, which is 2, and then raise it to the 4th power, which is 16. This one right here, 625, take the 4th root of that. What's that? That is 5. And then raise it to the 3rd power. Okay, so your denominator is what you're taking the root of. Your numerator is what power you're raising it to. Okay, so letter D, you're taking the square root of 49. That's what the 2 is, which is 7. And then you're cubing that, which is 343. Good? 125, you're taking the cubed root, which is 5, and then you're raising it to the 4th power, which is 625. Yep. Okay, tell your neighbor what you got for letter F. If you haven't done it, get it done. Okay, so if you try this the way we were doing them, is the cubed root of 100 an easy one to do on your head? How about 100 to the 6th power? Go ahead, Kai. Yes, that simplifies. 100 squared. Well done, Kai. Yes, simplify the 6 divided by 3 to get 2. Gives you 10,000. Woohoo! Questions? Your assignment is page 126 and 127. Before you freak out, they're not all that bad. Okay, you'll be okay. I know. 126, 127.